All right, next question, find an equation for the hyperbola described. Graph the equation. You have foci at 3, 4, and 3, 8, and a vertex at 3, 7. So we're going to go ahead and graph the information that we know. So we have a point at 3, 4, it's going to be here, and a point at 3, 8, so here. So those are your foci, and your vertex is going to open towards the foci. You also actually have a vertex of 3, 7, so you have one right there. So this is going to be opening up and down, so kind of like this. Okay, I have one vertex here. It is 1 away from the foci, so I'm going to have another one right here, 1 away from the other foci. Okay, so I have that. Now, because this is going up and down like that, if I take a look at my formulas over here, up and down, we're going to be following this formula here. It looks like this. So y squared is going to come first. So here you have y minus k over a, x minus h over b. So we're going to be following the formula y minus k squared over a squared minus x minus h squared over b squared equals 1. All right, so we have the foci and the vertices, but we have to actually get the distance in order to get A and C. So the distance for A and C is going to be the distance from the center of this. Well, we need to find the center. If we look at the graph, you've got a center right there. So it's actually really easy to spot once you have a few points on your graph. So that's my center. Let's get the coordinates for that. So it's going to be 3, 6. Okay, so that's my h and my k. Okay, you have a center at 3, 6. And that's your h and your k. Okay, and then let's get our a and our c. So a is going to be your major axis vertices, which is just your length. So from the center, 1. We'll just go up 1 value from the center. So a is going to be 1. Okay, and then c is the length from the center again. So 1, 2. So 1, 2. 2 values from the center, that's going to be your c. Okay, so I have a and c. Now I need to find b. So I'm going to use c squared equals a squared plus b squared. That's what's going to go along with the hyperbolas. And that's going to be, let's see, c is 2, so 2 squared equals 1 squared plus b squared. So 2 squared is 4, 1 squared is 1. If I subtract a 1 here, I'm going to get 3 is b squared. Okay, so then I'm going to plug all of these in. So I've got y minus k, which would be 6 squared over a squared. A is 1, 1 squared is 1, minus x minus h, my h is 3, squared over b squared is 3, equals 1. Okay, and that's the equation for my parabola. Now we do also want to graph it, so let's go ahead and graph this. Let me erase some stuff on here so we can make it nicer. Okay, so we had, let's see, we had foci at 3, 4, and 3, 8. We had a vertex at 3, 7, which means we had another one at 3, 5. Okay. And then we have that center. All right, so we have that. And then our asymptotes, so we need our asymptotes to make this work. So your asymptotes are going to be y equals, let's see, plus or minus a over b when you have a y squared. Okay, so the a here is 1 and the b is the square root of 3. Oh, that's a pain. Okay, plus or minus 1 over the square root of 3x. So when I'm doing this is going to be up 1 and over, let's see, 1.7. Okay, so if I go up 1 and over 1.7, maybe like right there for my line. up 1 over 1.7, like maybe right there, and down 1 over 1.7, maybe there. So something like that when I'm making these asymptotes. Let's see. So roughly like that, and then roughly, oh, that's not good, roughly, hold on. There we go, like that. Okay, and then you can go ahead and you can draw this. So when we're doing the asymptotes, the actual equation when you have a center that's not at 0, 0 is y minus k equals plus or minus a over b x minus h. Okay, but I just do like this because I'm doing it from the center when I do it instead of doing the whole equation. So this is fine if you're just graphing it. If you're asked for the equation of the asymptote, this is going to be plugging it in the equation. And then draw it. We're kind of not touching this, but I can't help it. So you're going to look somewhat like that when you're drawing this hyperbola. And that should be everything you need for this question.